Wonderful. So now we have hyperparameter grids for our logistic regression model as well as our random forest classifier. Let's tune each of them using randomized search CV. So now we've got, just repeat what we just said, got hyperparameter grids set up for each of our models. Let's tune them using randomized search CV. We'll change that into Markdown. Wonderful. So first up, we'll go tune logistic regression. Now at the moment, our logistic regression model, if you scroll back up, is getting the best results just on a single train and test split. But let's see if those results carry through to a cross-validation split, which is what randomized search CV is going to help us with. So tune logistic regression, we'll set up a random seed so that our results are reproducible. And then we're going to go set up random hyperparameter search for logistic regression. So RS for random search, log reg for logistic regression, and that's this log reg grid. That's short for logistic regression. That's short for random forest up here. We're going to go randomized search CV, logistic regression, wonderful. And then we're going to go param distribution, which is equal to our log reg grid. And we're going to use a cross-validation of 5, which is similar to what we've seen here. So 5-fold cross-validation. You could use 10-fold, you could use 20-fold. What you should know is that the higher this number, the longer it's going to take. So because it has to build a model for each and every single set. So 5 is generally a pretty good value to use. Again, you might want to test that experimentally depending on the size of your data. Number of iters equals 20. So that means an iter means we're going to try 20 different combinations, which I think will be every single one of them because we've only got 20 different values for C here, but that's okay. So we're going to go then verbose equals true, which just means it's going to output a few things for us. Now with that, we can go fit random hyperparameter search model for logistic regression. So what this is going to do is call randomized search CV. It's going to cross-validate a logistic regression model 5 times for 20 iterations. So we should have about 100 or so examples, 100 or so different tests. 5 times 20 is 100. We're going to fit this on the training data. Wonderful. Oh no. Param distribution. Oh, shons. There we go. Fitting 5 models for each of the 20 candidates, totaling 100 fits. Wow, and that's done. You see, oh well, it's zoomed in here, so you can't really see. It's going to tell us what the parameters are that it's used. And see here, we can see param distributions. C is all these different values here. Solver is lib linear. Let's zoom back in because it's easier to see. And now, we can check the best parameters by going rs log reg dot best params is solver lib linear, that makes sense, and the C value is 0.233. Wonderful. And so now let's evaluate log reg dot score on our test data. 88.5 accuracy. So if we go back up here, did we beat our original result? 88.5. No, we got equal to it. The logistic regression model out of the box must be pretty good. Because we've only tuned 2 hyperparameters, you could look up more different values that we could tune. But we're going to leave that here for the time being. We're going to see what it's like to tune our random forest classifier. So we'll put in a little commentary here. So now we've tuned logistic regression. Let's do the same for random forest classifier. Markdown, wonderful. And we're going to do the same thing again. Set up random seed. Now we could just copy the code from here and just change the variables. We're in the habit of writing it out, you know. dot random seed, we're going to set that to 42, our favorite number. So setup, random hyperparameter search for random forest classifier. Wonderful. We're going to go rf equals randomized search CV. Wonderful. We're going to put in our random forest classifier. And then we're going to pass it param. We'll just use tab autocomplete, so we're not doing typos here, Daniel, come on. Like we did before. So we're going to pass it the RF grid, which is the random forest grid. So our hyperparameter grid up here. So we'll come down here. What's next? CV, we're going to set that to 5, so 5-fold cross-validation. Number of iterations is going to be 20 again, so we're going to try 20 different combinations of these hyperparameters. Now, if we were to add these all up, so this is 50 times 4, 200 times 2, or actually, yeah, times the space between here. So this is going to be a lot more. Let's just leave it at that. There's going to be a lot more different combinations, but we're only going to try 20 of them. So randomly try 20 of them. So verbose equals true. Then we go fit random hyperparameter search model for random forest classifier. Wonderful. And we'll go RF, which stands for random search, random forest. Fit. We'll do it on the training data. Ytrain. Wonderful. What's happened here? We've got something wrong again. Invalid parameter. Mid samples lead. A typo. The classic. Min samples lead. I hope you noticed that when I was going through. It's alright if you didn't, because I didn't notice it either. Now we'll run this. So this should work. This might actually take a little while. Hope not. If it does, I'll pause the video and we'll come back when it's finished. Well, we just finished up, so that took about a minute or so on my computer. It'll also depend on how fast your computer's processing speed is how fast it goes through this sort of process. It does have to build 100 different models. So let's check it out. Now that it's finished, how can we find the best parameters of our random forest random search model? You might already know this, because we just did it with the logistic regression. It's okay if you don't. Find the best parameters. This takes a little bit of practice. Find the best hyperparameters. I'll give you a second to think of it. Hint, it's in an attribute. It's in an attribute of this one here. All right, let's figure it out. So we're going to call the best params attribute. And so this is going to show us our best parameters. So number of estimators, the best results were 210. The best min sample split was 4. The best min samples leaf was 19. And the best maximum depth was 3. Remember, that was only 20 different models. So 20 candidates. We could increase this to 100 or something. That would take a little bit longer. But in our case, 20 is enough. We're focusing on the principle here. We could revisit this in a second to try and improve our results. But what we're trying to do here is just minimize our time between experiments. So let's figure out how our random search, random forest model went. So evaluate the randomized search, random forest classifier model. RF score, X test, Y test. How did it do? 86.88. Let's go back up here. How did it perform versus our original scores? Oh, we got a little bit of an improvement. Yes. So this is our initial random forest model. 83.6 accuracy, because remember if you times that by 100. But even though we've gone up a little bit, we've gone up a few percentage points to 86.8. We can check out the original one here, model scores. Our logistic regression model is still, our default one is still better than the random forest, than the tuned random forest. Now, of course, we might be able to try different hyperparameter combinations to try and push our random forest model further. But what we might do is, because we're trying to minimize our time between experiments, we might push on with our logistic regression model. So now, you see how we're going through this process of elimination? Trying to figure out which model works best for us, which doesn't work, and then just slightly incrementing on the one that performs the best. That's where we're up to now. We're well and truly in the experimentation phase of this 6-step framework. We're trying out different models, we're trying out different hyperparameters. So now we've searched better hyperparameters for our logistic regression model back up here using randomized search CV. What we might do now is use grid search CV, which exhaustively searches through hyperparameters. Rather than randomly looking at different combinations of hyperparameters, as we saw in the scikit-learn section, grid search CV, and you can look up the documentation for this, sklearn grid search CV. Grid search CV searches an exhaustive search over specified parameter values for an estimator. So that's what we might do now with our logistic regression model. There's a couple of steps for hyperparameter tuning. One, you could go by hand. 2, randomized search CV. 3, grid search to really narrow things down. That's what the process we're following now. We eliminated KNN with tuning hyperparameters by hand. We eliminated our random forest model. Again, we could always revisit these things. This is part of the experimentation using randomized search CV because our logistic regression model is performing better than our randomized search random forest model. So now we're going to use grid search CV with our logistic regression model. So have a little review of what we've done. See if you could try a different hyperparameter grid for each of our logistic regression and random forest in our randomized search CV. See if you can try some different parameters. Maybe you increase the number of iterations. See if you can push those results a little bit. But for now, in the next video, we're going to focus on tuning our logistic regression model using grid search CV.